Hi everyone. First of all, thanks for joining this webinar today. So this webinar is going to be a bit different from the usual one. It's going to be a bit more code oriented, a bit more technical, let's say. So what we are going to see is how you can create a service or a module on o²SPARC from your existing code. That can be code of different kind. We'll see in a moment what we mean. First of all, a quick introduction about who we are. So we are the SPARC program, which is an NIH-funded program with the aim of stimulating the peripheral activity to relieve conditions. And the idea is to develop new therapeutic devices to control and modulate the organ function by working with the peripheral nervous system. This is a promising option for diseases such as hypertension, gastrointestinal disorders, and much more. The SPARC program consists of investigators, so researchers who produce data, but also the Data and Resource Center, also DRC. So DRC is an infrastructure built around 4 cores. We see them represented here. So we have a computation core, computation and simulation core, one for data coordination, for data curation, and one for map synthesis that builds scaffold of the organs. And I work for the IT's Foundation, so I'm from the computation and simulation core, or SIM core. And one of the main products we develop is the o²SPARC platform. The DRC and the investigators meet virtually in a place called the SPARC portal that you can access at sparc.science, where you can see all the things that have been developed by SPARC. So I was mentioning the o²SPARC platform. So this is the computation and simulation platform for SPARC. If you don't have an account, you can request one. If you have one, you can access it from this URL, sparc.io. In o²SPARC, you can do many things. You can build pipeline in different models. You can share your pipeline, and everything runs from your browser. So you no need to install software or manage a cluster on your own or other complicated steps. There are many resources available. If you like coding, there's Jupyter Lab with different type of things you can do. There are numerical solver, there are 3D anatomical models, there's facility to do CAD modeling, and much more. You have access to computing power from your browser. You just need an account. And although today we are a bit more focused on people who code, the platform is actually not only for people who like to program, but there's also a way to develop very easy application. And this was presented in our previous webinar a few months ago. So what we are gonna see today. So we are gonna dive into the code that creates a service on o²SPARC. For this, we recently released a Python library called cookiecutter o²SPARC service. This is what we are really gonna look into details. This is an open source library, and the idea is really to give it to you so that you can start to develop your service. Of course, you don't have to do everything alone. We're always here, and we want to actually develop this even more for you. So we'll be really happy to receive your feedback about how this works. o²SPARC works by using Docker. You don't really need to know a lot about it. So Docker is a technology to build basically containers, so you can build machines with all the software installed, all the things you need to run. And this is why it's very easy to create pipelines on o²SPARC and to make them reusable, because we use this technology. So you see a bit that we look into some Docker details, but really not much. So at the end of this webinar, what you'll be able to do is actually build a piece of the platform, because you'll be able to bring your own models into the platform. So we are going to follow these steps. So we will see very quickly something about the platform, since maybe you never used it. In particular, what are these services? We will see how you can have access to this cookiecutter library and how to run it. Then we'll go really step by step by using this cookie cutter. So there are 3 files that we need to modify to create our new service. One is the Docker file, so that will create our Docker image. So one of these blocks that are part of the platform. We'll see how you can design the inputs and outputs of your code. So how we can create an interface for that on the platform. So this is another file we are gonna look into. And then we'll see the final steps, so how you actually execute the code you might have and how you can test that everything works as expected. And at the end, we will have time for questions. It's going to be a bit dense today, so I'll really try to have some time for that as well. So a bit of recap about the platform. So when you go to o²S²PARC.io, you are in the dashboard. So here you see different tabs and you see the different studies you have. And this is an example of a study, is represented by this study card. When you click on a study, you open it basically, and you are in this other view, the workbench view. So here is where you actually build pipeline, you connect different blocks, different service. And this is actually a service. This is what we are gonna build today, and we'll see really what is behind that. Another small detail we need to remember is that we have 2 types of services. So we have computational services. These are an example. They have this icon here. A computational service is a black box. So there's code inside, is immutable. You can run this. You can then build bigger pipelines. And this is actually what you can build with the cookie cutter. So this is really what we're gonna look today. There are also other services, the interactive ones that have a full GUI. And for that, we don't have yet a cookie cutter, but the principles are very similar. And we can discuss more in detail if you need to onboard something that has a GUI. So let's dive a bit more into a computational service. So here I have another pipeline with one computational service. What are the characteristics of a computational service? So it has an interface here where you can define the input. So you can change, and people who are going to use your service can, for example, play with different parameters. Computational service has a run button. So when you click on that, the code that is inside is going to be run. You can check in this other view, the logger, what is going to do. So if you have some, for instance, some progress bar in your code, you're going to see what is happening here on the platform. So why you might want to create a computational service. So let's say, for example, you have a model of the vagus nerve that accepts as input parameters some parameters of the electrode, for example, the shape or the number of contacts, and it gives you as output, for example, their recruitment, so the number of fibers that are recruited. So this is an example of code, so a model that can be put in one of these blocks, and you can then, we'll see how to build an interface for it. So the inputs, you can define them in the UI instead of, for example, giving a command line from your code. Then the service will run, you can check the progress, and then you will see the outputs in this other, while clicking on this icon, you will see a similar interface. So let's look at this cookie cutter. What is that? So the cookie cutter is a Python library that you find on GitHub on our organization. It is open source, and it's rather easy to use. If you ever use Python, it's really, really easy. So here you have really the minimal instruction you need to use it. Create a Python virtual environment is the recommended solution to do that, and then you install this cookie cutter. So what you need to have to develop your service using this cookie cutter, you need your code, of course, for example, the model of the vagus nerve we mentioned before. You need to know a bit of Python and Linux terminal, because this is where we are gonna work. As I mentioned before, very little knowledge of Docker. What you really need to know is something that you can very easily Google, so you really don't need to be an expert on that side. It's nice if you have some knowledge of Git and GitHub, because this is the channel we're going to use between you and us to give us your code. So if you can put everything on GitHub, we can reuse a lot of the pipelines we have to really check that everything works. You just need to also follow the steps. We'll see in a second where to find them. So this is so this cookie cutter has been the result of quite a bit of work from our side, from the development side. So we think now it's mature so that people can use it, but of course there are gonna be some bugs, maybe things that we didn't envision, things that are not clear. So of course you can always write to us at support, mentioning that you're working with the cookie cutter, or if you really see some bugs, or also you have just some question on the same GitHub repositories, there are issues. So if you have worked with GitHub, you can just create an issue for us and we'll follow up on that. So let's start with the cookie cutter. So to use the cookie cutter, you just go in your terminal and you type this simple command, cookie cutter, and then you give the URL of the GitHub repository we've just seen. When you do that, you'll be prompted to insert some information. So you just type them in your terminal. So for example, the name, your name, the email address. You have to choose a name for the project, for example, vagus nerve model. Then all these others are derived from the project name. You can leave them as default. Another thing you have to choose is from which Docker image you want to start. So for instance, one good choice can be Ubuntu 18. So it means that the service will be built on a machine that has this operative system installed. This also can be changed later. So once you have done that, you will have a directory structure that really helps you organize how you should organize your work. Small detail, if you like coding, I really recommend this text editor. It's called Visual Studio Code. It really helps in developing, also using Docker. It's really user-friendly. So we'll end up with a number of folders, and we have a README file. So what we are going to see today actually is really the workflow you should follow to use this cookie cutter. So here are the steps we are going to follow. So the first thing you would have to do is to put your source code in the src folder. So here you put all your files. For example, if you have one main Python file or MATLAB file, you put that there. You can have other files. The important thing is that you have everything that needs to be used in that main file. As I mentioned, you can add print statements, progress bar in your code as you would normally do, and this will be shown in the logger in the SPARC platform. So let's go back to the steps. So the first thing you have to do is to modify the Docker file. So the Docker file is basically a configuration file that actually creates a machine, a full computer. So you have to imagine that you need to run your code in that machine with the additional libraries you might need. And this really depends on the base image you find. So here on the left, I'm showing what the Docker file looks like in the cookie cutter, and on the right, I have an example of an existing service. So to see how it looks like in the final product. So you start from a specific type of image. So we said we use Ubuntu 18. This is your base. In this other example, we are using another one that has Conda inside to install Python, for instance. And then typically what you will need, so also in the Docker file, you'll find instruction on what you have to do. So normally you can also follow what you see there. So normally the first step is to install additional packages you might need. So for instance, in this example, we needed Python 3 and other additional libraries, so you install them at this point. If you're curious, here I'm giving some information about the Docker statements. So you see these blocks that have are called with run. So this is basically as running a command in your terminal. What happens in Docker is that every time you type run something, it builds an additional layer on your image. So normally Docker images have different layers. So this is really useful to rebuild part of it. So it's much faster. Only drawback, if you put a lot of run statement, then the final image might be a bit bigger. So because it has to store more information. We see the env statement. This is to create environmental variable you might need for your code, for instance. And this is equivalent to do an export of a variable in your terminal. So the second part of the Docker file is where you build your code if it's needed. So for instance, this is an example where we need to do such a thing. For example, we have some C++ code that we need to compile before running. So typically in this middle part of the image where you see the from base to build is another layer of the image. You install, for example, G++ to compile your C++ code, and then you compile that. So why do we do this step-by-step thing? These blocks, these structuring blocks, is to basically reduce the final image size. So when you have, for example, built your C++ code, you can just throw away G++ because you don't need all these dependencies for building. Here we see another interesting Docker command is the copy. So, for example, in this statement, we are copying what we put in our source folder. So this is the code actually into the container. So you cannot just copy from your local computer to this image we are building. So you should use the copy statement for achieving such a thing. So the last step of the Docker file is to finalize it, clean up dependencies you need, and then define how this is gonna start when we click on the run button of the service. So we are on the production layer. Normally, when you run the service, you are in your home directory. So this statement here normally shouldn't be changed. And then what is done here basically is to copy again the command line interface. We're going to see in a second how that works. And again, you can copy additional things you might need. And this is what is going to happen when you launch the image. So this bash script is going to be run. And normally you shouldn't need to modify it, actually. So good, we have our, let's say, virtual machine that we built with Docker files. So how do we define input and outputs for the service? So now we look at the second step in the workflow. So we look into the .o²SPARC folder where we have a metadata.yaml file. This is basically what defines the contract between your code and o²SPARC so that we are sure that everything is compatible. So basically, this YAML file should be quite intuitive, and there's basically a one-to-one correspondence between what you put in this file, so for instance, the inputs, the number of input, and the type of inputs, and what you are gonna see in the UI. So for instance, this curve geometry here is the second input, and it has a type NaNum, so there is 4 possible values. And this is turned into a drop-down menu into Spark. You can also have simpler types such as numbers, strings. You can also have files. So what will be displayed here is just a file name that you can add into the platform, and you can give it as an input to your service. This is fairly easy. The first parts, version and so on, you should modify them. And this is also what you have given when you started the cookiecutter, so the name of the project and so on. Interesting thing, you can add a thumbnail, for instance, so you have a nice image associated with your code, which is always very nice to see. So we have the Docker file, we have the input and output mapping through this metadata YAML file. And now we just need to set up the execution of your code. So here you should imagine that you are in your terminal and you are gonna run your model. So how do we do that in a service in o²SPARC? We look at the third input that needs to be modified. This is the execute file, which is part of this service.cli folder. This is a bash script that basically what you need to achieve here is really to run your code, retrieve the input you have defined and that we have in the platform. And then if there's output you need to retrieve, also you need to add some statements in this execute.sh script to obtain them. So how does this file look like? So this is how you find it in the cookie cutter. As I was saying, normally you run your service and your code from the home directory of this, let's say, virtual machine we just built. So you need to retrieve the input. So what is done under the hood is that each input you have defined for your service is going to be available in an environmental variable. It's all explained here. It's called, for example, the first input is input 1 or capital. So you can retrieve them by just calling this environmental variable. Then, so you get all the input, then you would give them to your code, to your command line, or to your main script, depending on what you are developing. And then you can retrieve the outputs. We have two different output types. So if it's a variable, we would have to put them in this JSON file. If it's a file, you can just get them from the output folder. So let's see an example of an execute file. So this is an example of a C++ program. So here we are going in the folder where we have the source code. We are retrieving the inputs, and here we are running, for example, this C++ program with the input files. And then when it does run, we can retrieve the output. So for instance, if we want to retrieve a file, you just copy the file that has been produced by your code, and you move it to this output folder. Again, this is another environmental variable that is made for you. If you want to have it displayed in the GUI as, for example, a number, you add it to this output JSON file. So we are basically done. So we are already happy if you sent us your code in the cookie cutter, but maybe you might want to test before. It's not required, but I think that will be something nice also for you. So when you go back to the folder that has been created by the cookie cutter, there's something called make file. So there are some recipes that we built for you. So if you type in your terminal make help, you will see a bunch of commands that you can use. One that is it's probably very important to run is the build. So when you type in your terminal make build, this is gonna go through the Docker file. So it's gonna create a Docker image. Of course, you need to have Docker installed on your machine, but it's also rather easy to do. So you make build depending on the complexity of your code and the Docker image you're building. It may take some time. You probably have some errors. I always have when I build a Docker image. Normally it's easier to understand because it's really the same error you would have in your terminal when you do something wrong. So first, let's check that the image builds. Second, you can really try to run this service. So this is also something you can very quickly find on the internet, how to create a container from the image. So basically, it's gonna create an actual instance of a machine from this Docker file. So if you type Docker run the name of the image you just built, you're gonna be really inside this machine, so you can actually try to run your code to see if all the inputs are available or not. And after you have done that, we are really happy. So you can push the code to the GitHub repository. and then we will take it from there. Interesting thing is that when you push the code, normally there's a GitHub action we have configured for you. I don't know if you ever used GitHub action, but this is basically an automatic pipeline that is gonna do again the build of your image on another machine. So there you can even double check that everything runs as expected. If you cannot put the code on a public GitHub repository, you can just message us and we will work with you to create this service. If you really want to be a pro, actually, there's a third thing you might want to do. It's not described here because it's really something that normal user might don't want to do probably, is to basically build o²SPARC, the full platform on your machine. And there you can really put this service into the actual platform and see that everything appears as expected. But as I said, there's no need to go so deep into the development. Some resources in general and specific to this webinar. So this again is the GitHub repository for the cookiecutter. Is on the IT's Foundation GitHub account. In general, we have documentation about the platform. Is online at this page. Also on the platform, there's this book icon that brings you to the documentation. This is the source repository of the full platform. So this is where you would go if you want to do this very advanced thing of building a local deployment of the SPARC platform. And of course, on our YouTube channel, you will find a recording of this webinar, but also other webinars developed by SPARC and by us, SimCore. Any questions at this point? Also feel free to add them into the chat.
Are there any limits we should be aware of, like number of nodes, compute time, storage space, that sort of thing, and creating these modules?
Yeah, so actually, yeah, there's something that we didn't feel it's would be too much overhead for a user, but actually there's an additional file where we define these things. So for the moment, there's not really limits. So we run different type of machines on AWS. So for example, some of our biggest services require at least 16 gigabytes of RAM. They might require GPU. So there's not really big issues there. But yeah, of course, if you have specific needs, it's good to get in touch so that we can see if we have everything you need. Yeah, one of the things I was mentioning was the size of this Docker image. So also there, you have to keep in mind that if the image becomes very big, it basically slows down a bit of things, specifically the development of the service. So if you can get rid of unnecessary dependencies, for instance, will be nice. And image size, we have some that are up to 20, 30, even 40 gigabytes, but I would say staying below 20 will be a nice thing to do to speed up everything. I hope this answered your...
Yeah, thanks. Can you change the dependencies based on the parameters you set in the that UI you were showing?
No, actually, when you have your service, your block is frozen, so it is what has been defined in the Docker image. But it is very easy to make a new version of the service. So in that case, you will probably tell us that you need to update, or you can also make a new version of the service with the required libraries. But yeah, you need to modify this Docker file, basically.
I see. That's great. Thanks.
I have a question. Is there is Cookie Cutter doing sort of a lot of work to standardize the names of variables or sort of turn the inputs of your model into what o²SPARC is expecting, or are there strict kind of rules for how you have to name things so that they will be picked up by the by the translation?
Yeah, I
I think I'm
mean,
not explaining it exactly right, but
no, I
hopefully
think I might have understood. So actually, the idea of the cookie cutter is really to put everything so that we are sure that it's compatible with o²SPARC, and this is actually what it is about. So, for example, that metadata file, you have to have for example, the input have to be called in a specific way, input 1, 2, 3 other fields are also need to be to have specific names. So for example, this key here shouldn't be modified. This is what actually is used by the platform to get all the services. Also the keys here, they have to be like that to be compatible. What is in here, you can write basically whatever the types we support for the inputs are. Actually, they're based on a thing called JSON schema. So actually, it's a standard that is used widely on the internet. This is what makes us very easy to generate GUIs from that.
yeah.
And all the rest, I mean, it's all in this cookie cutter. So the execute file is what is gonna be launched. So yeah, this is actually the whole purpose of the cookie cutter, to really make sure that things are compatible.
That's great.
Yeah, I mean, we know that it's, as I said, it's more, programmers oriented for the moment. But yeah, the next step will, first to see how users use it and if it works. And second is also to make it like more like having a GUI to actually create a service will be really the end point. So that is not so technically heavy, let's say.
Yeah.
Any other questions? Okay. If not, I thank you all. You can check other webinars online, and feel free to get in touch. You also have, I think, my email since I sent you one earlier, so also feel free to get in touch for any type of questions.